I don't know who put those 2 ticks. Okay. So middle primary 2, making polygons. So Alice has several plastic tiles consisting of squares, equilateral triangles, and regular hexagons. Does everyone know what an equilateral triangle is? Yeah. So a triangle that's equilateral has all the sides the same length. So that means this side and this side and this side are all the same length. And then the square is the same, but with 4 sides. All sides have the same length, but yeah. And this is perpendicular, it's a right angle. And regular hexagons, again, it's just a 6-sided shape with all sides the same length. And all these angles are the same as well. Okay, so all regular things. Alice wants to make other polygons. Okay, so everyone knows what a polygon is? It's just a shape which has, oh no, where'd it go? Please don't do that. So Alice wants to make other polygons, which are just other shapes that have straight edges, by putting these tiles together edge to edge so that the edges meet exactly. So that means all these edges are the same length so that Alice can just join shapes on as she wishes because all the edges are the same. Okay. But Alice can't do this kind of thing where she makes the edges not meet exactly because there's a gap here that hasn't been touched and then there's a gap here that hasn't been touched. So that's not okay. Okay.
Yeah.
So this is allowed, this is not allowed. Alice.
Yeah,
because
the square's not touching.
Yeah, because the square's not fully touching on one side. There's like a little gap. Now, Alice put 3 of her tiles together to make polygon A. So this polygon is just the shape created by putting everything together. So it kind of looks like a house with a room coming out of it, doesn't it? So yeah. Let's count how many sides. It's got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6.
No, like it's the 4 and 3 needs to be connected.
Yes, thank you. Okay, so if it's a straight edge, then that counts as 1 side. Silly me. Okay, so that's 3, 4, 5, and 6. Okay, so it's a hexagon because any shape that has 6 sides is a hexagon. Someone want to tell me why it's not regular though?
This is because it's not like a shape.
It is a shape because it's just like a house.
Oh my.
So what makes it not regular? It's a shape. It's definitely a polygon. Why is it
like it's because it's not like normal size. Like some are long, some are diagonal, and yeah.
Ah, okay, good. So you realize that regular, all of these are all regular. These are all regular. And so there are a few things that happen: equal sides and also equal angles. So these sides are all the same length and these angles are all the same. These angles are all the same as each other and these angles all match. So yeah, this doesn't have equal sides because 3 is longer. So even though all the other sides are the same length, 3 is too long. And also not equal angles. Because these are right angles. This one's bigger than a right angle. This one's actually a reflex angle because it's even bigger than a straight line. And this one's smaller than a right angle. So not regular, and that's why. Now, reflections and rotations of a polygon are considered to be the same. Okay, so this shape as a polygon is equal to this shape as a polygon, and it's also equal to this shape as a polygon. Because to get between these two, we just flip it along this axis, right? It's the mirror image. So it's actually the same shape, it's just the mirror image. So we're gonna say that if it's a mirror image, it's still the same shape. And then to get from this one to this one, does someone want to tell me what happened? Why are they the same shape? What's the difference? So for this one, we just had to flip. What about for A to C? Anyone have an idea? Why is it the same shape, and what has changed?
What?
It is just turned a little bit.
Yeah, it's turned,
Yeah.
right?
And it's still the same shape because it you didn't put any extra things. It just turned.
Yeah, okay, good. So we turned it. We turned it in this direction by a 90-degree turn. And for those who don't know what 90 degrees is, that's just the angle.
Just a quarter.
Yeah, it's like a quarter of a turn. So if this is the whole circle, 90 degrees is just going a quarter of the way around.
Yeah.
Yeah. And yeah, there are no extra sides added. There's still 1, 2, 3, 4. Sorry for writing sideways. 5 and 6. Oh no. And 6. And they're also still the same length with the same angles. So it's still exactly the same shape. This one's the reflex angle. This one's the one that's smaller. Okay. So all of these are the same. Okay, now let's do some questions. Question time. Questions. So let's start with A. If you know the answer, then don't spoil it, please. But if I say that you can tell me a clue, then I'll allow you to spoil it a little bit. So Alice selected 4 of her tiles. Okay.
Yeah.
So let's remember, what tiles does Alice have?
She has 4 tiles and she used 2 of her tiles to make a pentagon. So you got make one pentagon and make another one, but in a different way.
In a different way. So yes. So okay, let's start with, what tiles does Alice have to select from? So what types of tiles does Alice have again?
A square and
Yeah.
a triangle.
Yeah. An equilateral triangle. Yeah. And there's one more. There's also the hexagon, the 6-sided one.
Oh, yeah.
Yeah. So Alice has all of these.
Yeah. So she uses the hexagon. Then you gotta like make the pentagon like connected to the hexagon.
Interesting. So 4 tiles, and she wants to make 2 different pentagons. And pentagons have 5 sides, right? So that's just a 5-sided shape. Okay, so I don't know who was just talking, but someone mentioned that they want to use the hexagon. And if you would like to use the hexagon, then there's only really one way we can do this, one possible way. And the reason for that,
Fine anyways.
I think that there actually is a way. So, I mean, how many sides does the hexagon have, everyone?
6.
Okay, is that good or bad? What?
It's kind of bad.
Yeah, it's in a way, it's kind of bad because 6 is bigger than 5 and we're trying to make a 5-sided shape. So that means if we add a shape, like if we connect a shape onto this, then the extra tile needs to make less sides. We need to somehow go from 6 to 5 by adding the extra shape.
So we use the triangle?
Yeah, okay, well, then can you explain to me why we can't use the square?
Because square is bigger.
The square isn't necessarily bigger. I actually think the square is smaller because the square fits inside the hexagon like this. So why can't we use the square? Can we use the square? And the spoiler is that you can't use the square, but why can't we use it? Remember, we're trying to go from 6 sides to 5 sides. Like if I connected the square somewhere, then it would look something like this, right? It would be like I have my hexagon, but then if I want to connect the square, then I have to connect the square to one of these sides, right? So like I could put it down here.
That would be like 6 minus 5 plus the extra 3 equals 4. So that means 5 plus 4 equals 9. No, but actually no. 5 plus 3. We don't need to minus. Oh yeah, 6 minus 1 because we used 1 like both together.
Yeah.
Plus 3 for the rest of the square.
Yeah, exactly. So it's like the 6 original sides, and then we minus this one because we just joined it into the shape. So that is no longer a side. And then we had to add 3 for the extra bits of the square, for the extra sides of the square that get glued on. And so that is 8 sides. And that's too big. That's not equal to 5, so that's bad. Bad. Okay? So can I ask you then?
We can't use the triangle because like if it's triangle, it's just 8 minus 1 equals.
So you think if it's a triangle, it would be, by the same logic, it would be 6 minus 1 because we get rid of this edge, but then there's only 2.
Plus 2.
Okay. Well, let's actually test it, should we? That's 7, and I agree that's bad. But I think that there's something special that happens when we use the triangle. So let's actually try to draw the triangle, shall we? That's what it looks like if I use the triangle because all the side lengths are the same.
Oh, there's something special. It's because that I was thinking of that. But then I was also thinking like the other squares don't do it, and then I thought of that, and then I was like, oh, I miscounted.
Yeah. So what's special about the triangle? It's special. Why do we not use the same rule to count the edges? Like, why is it not 6 minus 1 for this, and then plus 2 for these 2 sides? Because if we did this formula to count the sides, then that would be like counting 1, 2, 3, 4, 5, 6, 7. So what's wrong with that counting? The clue is that I made the mistake earlier when I was trying to count this shape here. Remember what I did first? That was a mistake. I tried to count this long side as 2 sides, but it's really just one side because it's straight. So what's wrong with this counting? Anyone want to tell me what's wrong with my counting here?
That's bad. Bad counting.
Wrong counting.
Wrong counting. It's because that, you know, like that, 1, 2, 3, 4, 5.
Mm.
But then that is cut off, right?
Yeah.
1 and 7 is one line. 6
Yes.
and 5 is one line.
Exactly. So I need to not count these sides twice. So actually the correct counting would be like this. It's like a house with 3 sides, isn't it? It kind of looks like a house. Anyway, so it should be like this: 1, 2, 3, 4, 5 sides. And that is a pentagon. Yay. So this works, actually. We can do this. This is good.
I can't find where your place, where your
It's like,
oh, bottom. Oh,
I think so. Yeah, I guess so. I don't really know. Anyway, okay. So let's compare that to the square side. Why was the triangle good and why was the square bad? What's the difference? Remember we tried to go from more sides to less sides? So we went from 6 sides, and then when we added the triangle, we went to 5 sides. How did that happen? How can you go to less sides by adding a shape? Anyone know? How did I go to less sides by adding one shape? Okay, well, let me tell you the secret. Over here,
No, thank you.
see how these are 2 different lines? This is one side and this is a different side. So we have to count them separately, right?
Yeah.
And that's because they don't make a straight line, not a straight line. So that's why we have to count these separately. And that's why this has 8 sides altogether. But then the reason that the triangle is special is because when I add the triangle on, it makes straight sides. So these are straight lines. And because of the straight lines, then I get to count less. So that means I can count less sides. And so basically, with the triangle, it's special because I create straight sides by adding the shape on, by adding the triangle on. And by creating straight lines, I can count less because the 2 edges join to become one edge. So the 2 edges become one edge. It's like we go from 2 edges like this, just to one straight edge like that, where these are the 2 edges that we joined, and then that created a straight edge like this.
there's
So that's
something weird with my computer.
maybe you can refresh the whiteboard.
Try to refresh it, but then like it was the same. It was weird.
I can't find that.
Maybe I'll have to refresh. But then if I refresh, I don't want to lose
To
it.
find this,
I'm not sure if you'll lose
I
it.
can't find it.
I'm pretty sure you won't lose it.
Wait, let's see. Yeah, I'm scared I might lose it because I can't find it on the whiteboard either, which is really strange, isn't it? Okay, I'll refresh after I finish going through this question, okay?
I'm
Okay.
whiteboard. I can't see your writing.
Okay.
Down the bottom, but the writing wasn't there.
Okay, so everyone just focus on the Zoom for now and
Yeah.
watch the screen on Zoom. And after this question, I'll refresh the whiteboard so that hopefully everyone can see my writing. Okay? So, does everyone understand why the triangle was special and why for the triangle we can go from 6 sides to less sides, 5 sides? It's basically because we created this straight line by adding on the shape. Okay, well, I have another question for you all. So let's still look at the hexagon. We're still looking at the hexagon. Just because we want to make sure that we consider all the possibilities with the hexagon. So you know how before I added the square by doing this? What if instead of doing that, I did this? Is that a different shape?
No,
Why?
because it says that it counts as it's the same because it's just on a different angle.
Yeah, exactly. These are all the same because it's just rotation. That's what it means to turn it. Okay, what about for if I add the triangle on?
Then that'll be a different.
Wait, compared to where I put it originally, which was up here.
No.
Are these the same if I put up here versus over
Yes,
here?
the same.
I know
The same.
another possible way of doing that thing.
Okay, let's get to
Getting
that
the
later.
triangle but putting it to the bottom.
Like down here?
Yes.
Yeah, okay, well, these are all the same actually, because it's just another rotation. So they're all rotations. Whoops, all rotations. Okay, now, so I think, and by the way, just so everyone knows that it's definitely makes a straight line, the reason that we know it's a straight line is, does anyone know how many angles there are in a straight line?
Yes, there's only 2. I mean, one.
Wait, in terms of degrees, how many degrees in a straight line?
360.
360 is a circle, actually.
Yeah, but like a straight line, half of it, 180.
Yes, 180. Okay, so the reason that when you attach the triangle, it makes a straight line is because equilateral triangles always have 60-degree angles. That's just a fact about equilateral triangles. They have all the same angles and they're always 60 degrees. And then another fact about...
Yeah. Can I say something?
Yeah, of course.
Is that like, if it's 60, the times like the whole triangle, that must be 180. So yeah.
Yes, that's it.
60 times 3 equals to 180.
Yeah, very good. So that's because there are 3 angles in a triangle, and the angle sum of a triangle is 180 degrees. That's the angle sum of the triangle. Okay, so if we apply similar rules to the regular hexagon, I'll tell you the rule for the hexagon. If you extend all of these lines outwards like that, so you extend the straight lines and make them keep on going forever, then we have another angle sum formula. So the angle sum of all of these external angles, we call them external angles. External, whoopsies, angle. So the sum of all these external angles, oops, I missed one, didn't I? There's also this one. Does someone want to guess what the sum of all the external angles is? If we add them up, plus, 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 plus. Well, the angle sum of all the external angles is 360 degrees because it creates a whole revolution when we turn around. It's like we start from here and then we turn a little bit to make the line go in this direction. And then we turn a little bit more to make the line go in this direction. Turn a little more to go in this direction. Turn again and turn again. And you can see that the line just went through a whole revolution.
Yeah.
Yeah, so that's why all the angle sum of the external angles is 360. How many angles are there?
6.
Yes. So that means that each one of these is 360 divided by 6 because there's 6 of them, which is, anyone want to tell me? Can you help me simplify this? Okay, what's 36 divided by 6?
6.
Yeah, so what happens when we add the 0 on the end?
360.
So 36 on 6 is 6, and then if you add a 0, what happens? Well, this is actually the same as 36 on 6.
There are actually 6 lines.
Yeah, there are 6 lines, which is why there are 6 angles too. 1, 2, 3, 4, 5, 6.
Yeah.
Okay, so that means each of these angles is actually 60 degrees.
Yeah. That is 60.
Yeah, which means that if I draw this out to be a straight line, the angle here is 60 degrees, which is the same as the angle in the triangle. And so that's why the triangle fits perfectly into this straight line slot. So that's how we can actually prove that the line is definitely straight when we add the triangle.
Yeah.
Yeah, and that's why it becomes a straight line.
Yeah, that's why.
Yeah,
That's so much writing.
it is a lot of writing. We did a
Now
lot
you
of
can
work.
refresh, right?
Oh yeah, I'm gonna refresh now.
Okay, let me.
That's ginormous.
It is.
I'm
Oh,
done.
what happened?
Leo.
Everything's gone. Okay, I think I'm gonna have to add the question back in, aren't I? It's okay, we can just continue doing the question one more time. Okay. So we haven't finished the question though. We only found one pentagon. Aren't we supposed to find 2?
I think so. Yeah. Yeah, we're
Mhm.
supposed to find a different one.
Yeah. So let's find a different one. We can't use the hexagon anymore because we actually looked at all the possible ways with the
Can
hexagon.
see a big smiley face.
Yeah. Yeah.
Who's that smiley face? Like who did it?
What?
Who did that smiley face?
I don't know. I didn't do it.
Wow.
I don't know.
Smiley face.
That's so big. Why am I always
Why does the smiley face have a little...
dick?
Who drawn that?
Hello.
Now someone's drawing another smiley face.
Wow. This one doesn't really look like a smiley face. It kind of looks like a nose. This looks like a nose.
Why is there so many now?
Okay, let's get back to work, everyone. Okay, so everyone look at my screen.
Yeah.
So we found one way to make a pentagon using the hexagon, and there's no other ways to make a pentagon using the hexagon. So this was one way. So that means we can't use the hexagon anymore. We have to use just the square and the triangle. So can I make a pentagon with these?
Yes.
How? Draw it.
Put the square on top of the, the
Yeah.
triangle on top of the square.
Yeah, I mean, there's really only one way to connect them, and that's to do this.
That was one of my solutions.
And none of these make straight lines. They all remain as different edges. And so the total number of sides is 1, 2, 3, 4, 5, which is a pentagon. That's the second way to do it.
Yeah.
And yeah, none of these are straight lines because we know this is a right angle, and we know this is definitely not a right angle. And on a straight line, we have two right angles.
Whiteboard is not at the chat when I just looked.
Oh. The questions disappeared. Somebody is naughty and keeps on getting rid of the questions. Okay, let's do.
Who is it? I can't go in the whiteboard link.
You can't go on the whiteboard link? Do you want me to
Because
send?
I can't find it. When I was looking in chat, it's not there. I'll send to everyone.
Okay, thank you. Wait, that's the wrong link.
Really?
Yeah, that's the Zoom link.
Oh, I'm going to go back to it.
Okay,
Just wait.
okay. I'll send it to everyone. There we go.
Yep.
Hey, someone keeps deleting the questions.
Yeah. I got it. I gave the link.
Okay.
I'm not
gonna have to put the questions back.
Who delivered the questions?
I don't know. It wasn't me.
Questions.
Okay.
Wait, where's the questions?
I'm putting them back now.
Oh.
But that means that we solved part A successfully, right? Because we found it in two ways. 1 and 2. This one and this one.
I think the next one we need to make an octagon with 1 hexagon, 1 square, and 1 triangle.
Yeah. Actually, let me ask a question. Can someone tell me why these two are different to each other?
Which
because
one?
we needed them to be different, didn't we?
Yeah.
Why are they different? So someone tell me why they're different. Okay, I'm gonna have to do this again. I'll draw it separately. So we have the hexagon. Wait, who keeps doing that?
I'm not doing anything.
Someone is not.
Draw.
Okay, so we had this one, and then we also had where these are just straight lines. And then we
this
also
one also.
Yeah, exactly.
Wait, I need to.
So why are they different from each other?
Right there.
What's the difference between them?
Connection lost.
The difference is that
Hmm?
first one was using this hexagon, and then the next one was using a square.
Yeah, and that's true. That's true. And what's the difference?
Using a triangle.
That's true. And then also the difference between the square and the hexagon is that this is a right angle. This is a right angle. And then these
This is
are
like
not.
a bended angle.
Yeah. These are like obtuse. These are bigger than right angles. So that means they're different because the base angles are different to each
This
other.
one is a curved one.
And that is really because it's a hexagon in the first one
Yeah.
and it's a square in the second. Okay, I'm going to finally, again, put these questions back.
Oh no. Connection lost again.
Yeah, no, it keeps happening. Okay, whoopsies. Let's move it down here, okay?
What? Oh. Here it is.
We all found it?
Yep.
Okay. Let's do part B. So we're going to look at this one. Alice took 3 of her tiles. So Alice took her hexagon, this one here, and 1 square and 1 triangle. So she wanted to put them together to make an octagon.
Yeah.
How many sides does an octagon have?
8. So we have to make a shape with 8 sides.
Yeah, good. And we need to find 2 different ways again. So we can only use one of each shape because that's what the question says. Wait, well, we actually already answered the question
You just
before.
rubbed it out.
We already answered the question before when we put the square on top, remember?
Yeah.
Like 6 minus 1
Yeah.
plus 3. 1, 2, 3, 4, 5, 6, 7, 8. So we actually already answered it in the first question.
Why is my computer so weird? Like I just below the shapes, I just see OC.
Wait. Really?
What's wrong with me?
Maybe. Oh wait. Oh yeah, I think it's I need to refresh.
I think I only saw O. I only see an O there.
I
I can only see an OC.
I only see an O.
okay.
Do you
I
mean
only
the
see an
math
O.
I can see now a blue thing. Like
now
here.
someone wrote Octagon.
Okay.
Oh, there's scribble.
That's
What? We just
This
rubbed it
thing.
out. All right.
There's this purple thing here.
okay. All right. Okay, so let me just show you guys again. We already found it in part A that if we put a square on top of a hexagon, we get 6 sides for the hexagon, but then we need to take away 1 because this edge has been lost.
Yeah, because it's staring.
Yeah. So that was one way we already saw. So now the question is, how else can we make a different octagon? We also already saw that if we move the square to a different side, then it's the same shape. So we can't just try to put the square on different sides because it's the same. And we also already saw that this makes a pentagon, that this makes only 5 sides. Oh, I have to refresh again.
Dot.
Mhm. So this shape is the same because it's a rotation.
Yeah.
And we saw that this makes a pentagon,
Yeah.
which is bad. And also,
Because you want to make an octagon.
yeah, and also all of these give the same shape because they're just rotations. So I think from that, we know that we have to use
I know a way. So like, you know the way that the first time that we used the hexagon and the triangle to make the you know,
Please refresh.
make the pentagon. We can draw that, and then we just draw a square randomly on one of the on the lines.
Can you repeat that for me?
Let me draw it.
Okay. So everyone agrees that it can't be a hexagon with a square because we already checked
Why
it.
does I need to
Yeah.
refresh? I need to refresh.
Okay. And it can't be a hexagon and a triangle because we already checked that case as well.
I
Yeah.
refresh.
Do I have to refresh or just you? No, I don't have to. I think,
I'm trying to
I
refresh.
don't need
but
to refresh.
It's not letting me refresh.
okay, we'll wait for you.
How do you refresh?
Oh, I'm pressing it multiple times.
Do you want to just tell me what to draw?
It's like hex a hexagon, then the triangle on the top,
Okay.
and then a square on one of the other sides.
Okay.
Draw it on a paper and
Oh, I
show.
know one way. I can just delete it and then just get it again.
Okay, let's check how many sides this has. So this is straight, right? So that's just one side. This is the second.
Oh, I
3,
can see it now. I can see it.
4, 5, 6, 7, 8. Oh, yay. So this is an
Yeah.
octagon.
Let me move. I can't see anything. I just see different.
Yay.
Just move to the bottom.
Where is
You
it?
have to refresh
Oh.
the page.
Well, then actually, I think,
Hexagon plus square, not hexagon plus. Oh, yay.
yeah, it worked.
Yay. I guess
Wait,
my.
and this gives me an idea. I think that we can make a lot of different octagons from this idea.
Why
What
do I
if we-
keep getting connection lost?
Yeah, I don't know, it keeps happening. What if we move the square or we move the triangle, but we use the same shapes? I think it actually works. So like if I keep the triangle up here, but then compared to the triangle, I move the square. So for example, if I move the square down here, it should be the same, shouldn't it? Or will it? Let's see. Let's count. Wait, why did you add another one? Let's count this one. So 1, 2, 3, 4, 5, 6, 7. No, that's bad. So that means we can't actually just move the octagon. We can't just move the square. So actually the square has to be next to the triangle.
What?
Square must be next to triangle.
Seven sides.
Yeah, and that's bad, which is why the square has
He's
to be.
going into connection
Like,
lost.
hey, I'm gonna draw it again and then I'm gonna count. Refresh again?
It's so there's like something.
Something's wrong with my computer.
There's something wrong with my iPad. Nothing wrong with
Program. Going down. Okay, let me
Okay.
out.
So can people see that actually we've answered the question? Because we found two different ways. So the answer for B in the end was this. There is the hexagon.
Oh
with
wait,
square. And then there's,
I just said like it's like any way is possible, but like I think that one of them is bad.
yeah, so one of them is bad. Like if you try to move the square over here instead.
Oh wait, I know
bad.
why. I know why.
Why?
We need to block the one of the long parts.
Yeah, exactly. That's why we have to put the square next to the triangle so that we can block this. It's so that we can block
There's
the lock.
also another way. Can I draw it?
Oh, you found
There's
another
also
way?
another way. Can I draw it?
Oh, you found another way? Okay.
Oh my, why is it so hard?
Its connection lost so many times for me.
Mm.
Maybe we both have bad signal.
I think whiteboard fox is just a little bit better.
I'm just gonna draw it next to the not hexagon plus square. That part.
Okay then.
Not what?
Not hexagon or square. In the
Plus
Let
square.
me see. Oh yeah. Oh, does it say hexagon plus square, hexagon plus triangle?
Who's rubbing my drawing?
Where? I can't even find it.
Someone is rubbing my thing.
Ah, I can't find it.
This, and then I just put the square here.
Where?
The
Wait.
other way. The other way.
Are you sure that's not the same
That's
as if I put it here? Why is it different?
this, and this is the same. Am
Yeah.
I wrong or something?
So I think what you just did is the same as the shape we already looked at.
Oh, it just flipped. Oh,
It's just flipped. Yeah. So actually what you drew was still the same.
okay. Let me out. Why is it zoom in? Zoom in. Zoom out. There's so much lighting.
Mm.
Yeah.
Oh,
Wait.
hey,
I just see
wait.
someone rap.
This is a little bit weird. I can see like us. I have my board, and then I can see another person's board. Like,
Wait, yeah, someone screenshotted a board and put it in. That's so confusing.
wait, someone did it again.
Wow.
And then he put it smaller, bigger.
Okay, everyone, I moved to the
Papa,
top
who
of the
did that?
whiteboard. I moved to the top of the whiteboard to do the next question. So follow where
That's
the
so
blue
weird.
star is.
That's so weird.
Find the blue star. That's where I am.
Well, it's not letting me do anything. It says refresh. But how to refresh?
Just delete your whiteboard account and then go to Zoom, press the thing again, and then it'll be fine.
Okay.
Wait, who deleted that? Ah, I have
Delete
to go
what?
back
Oh my
now.
gosh, I can see like 2 lines going so out.
Okay.
Let me do something, okay?
I'm going to put it back.
Okay, everyone, pay
Yep,
attention.
I uploaded it.
Ah,
Well,
thank you. Okay, we'll keep
Why
both
does
of them.
my computer always needs to refresh?
Let's keep both of them just in case.
Okay.
But we'll use yours. I moved it up.
Okay. In case someone deletes yours.
Yeah, exactly.
Let's go.
Okay, I have to keep refreshing. This is
Yeah, it's getting annoying.
Big board thingy. Let me.
okay. I'm here.
Let me do something. Actually, no. Let me write it.
Wait, did someone delete it again or no?
Delete what?
Did someone
No,
delete?
no one
Oh,
Why does
what are you guys up to?
We're doing part C now, but we keep on losing the questions. So can
Yeah,
everyone see the questions?
I can see your
What?
questions, but the thing is that I need to. My connection is lost,
Ah,
and your connection is lost also.
oh, my connection too. Okay, we'll refresh and then
Me
we'll
too.
do the question. We'll do part C, even if some people can't see the question.
Yeah, so this is where memorizing it comes in handy, hey people.
Okay, so now we're doing part C, okay? Connection
where is
lost
it?
again.
Oh,
Yeah.
right here.
Rip.
My connection
Hmm.
is lost again.
Okay, so part C.
Oh.
Let's pay attention
So
to
it does
part
make a little bit of difference what whiteboard I create.
What did you do this time?
I didn't sign in when I created the one, so it could be a bad one.
Ah, they've made they've taken all the bandwidth and put it to the people who actually pay, huh?
Oh, yeah, so I might sign in.
I can't find the blue star.
No,
I can't find the blue star.
it's
I
at the
found-
top. It's
Who
at the top.
just copyright their screen again?
I don't know who keeps doing this.
I don't know.
Right, I'm moving it out of the way.
Where should I
Just in
move
case
it?
it gets deleted, I think, probably.
Oh yeah, I can delete it. Okay.
Okay, everyone, I'm starting the question with or without you.
Who
So,
just
Where is
scribbled on the
it? Is
book?
it? Is
And
it?
then I need to get
Why is it scribbled? Why
Where?
does it say this? I'm here, star.
I hear a star. I can hear a star.
Connection was lost.
Let me do
Oh.
that.
so if your connection keeps getting lost, just focus on the Zoom screen because I'm starting the question now.
Okay.
Mm-hmm.
I just deleted
Who's writing
the one
Me.
that screenshot thingy.
and this
Another
scribbled on the
screenshot.
star?
So it's the same question. Alice has the same shapes, just one hexagon, one square, and one triangle.
Everything is the same.
Yeah, everything's the same except Alice needs to make 2 different polygons that have a line of symmetry. So 2 polygons that have
I need
a line of symmetry where you can flip in that line and the shape stays the same. So it's like the mirror image of itself. So for example,
Oh, this is so big. We just put a big screen thingy.
so I think we have to use all of these shapes, don't we? To make,
Excuse me.
Mm?
Why? When I just came in, I found like a question like A B C D, but like it's so large, so large.
Oh, wow, yes.
And there's no screenshot of there's again.
Okay, I'm
All right,
working,
Tristan, focus on this last part, okay?
I'm
I only
working
got a
in the
few more
top right.
minutes. I know it's past your concentration time. Brain bedtime.
Okay. Here. So, oh no. Okay, well, we don't need the question. We remember it. So Alice has the hexagon.
Yeah, it was like use 3 shapes to make a.
Shape which has a line of symmetry, but 2 different ones. Okay, who's deleting this?
I'm not deleting anything.
I believe-
anything.
I'm not deleting anything. Like
okay.
How come I deleted something?
why is it?
So does everyone know what a line of symmetry is? Like for
Yeah, I
example,
know.
Your line of symmetry.
Yeah, a line of symmetry is that one
It's like
the thing can get
a
cut
line
into
that can be folded.
quarters,
yeah,
and then
okay.
each
Like
part
when
is
you
the
fold it,
same.
when you reflect along that line, it's the same. So do people want to help me draw in the lines of symmetry on the other 2 shapes? I think this
Yep,
might help us.
I will.
Okay.
3 or 4. Put
I
a
think it helps that
What?
our building
that?
blocks have lines of symmetry in them, don't you? Okay.
Someone just draw the smiley face, I guess.
Wait. Someone's deleting my shapes.
What? I don't know.
I am definitely I didn't deleted it. I forgot to press on the whiteboard link. I'm going to.
I don't even know where you guys are.
Lines of symmetry on the other shapes.
Someone. Thanks,
Oh.
Jaden. You're welcome.
What's happening?
I just
No
like it
one's
was
helping me here.
you just deleted something.
Let me.
I thought I saw something got deleted.
Okay, do people want to help me draw the lines of symmetry?
I want to draw that, please.
I'll draw the lines of the symmetry. Wait, what's that?
Oh, so who hasn't done part C? Can someone tell me who has not done part C?
I think.
I've not done part C.
Me too. Well, I don't know.
Ah, thank you. Someone helped me draw the lines of symmetry. Yeah, these
I
are
need to
lines
go
of
to it.
symmetry.
Where are you even? Yeah.
They're in the top right of the board. Okay, so these are some good lines of symmetry. Okay, now that our building blocks have lines of symmetry, how can we put them together to still have a line of symmetry? Like, how can I glue them together to still make lines of symmetry? Okay, well, I'm lost. I'm just going to draw the lines of symmetry again here. So there's like lines like this. But then in the hexagon, we can also do this kind of line of symmetry. So I think that's interesting. This has two lines of symmetry. Actually, it has a lot more, right? We can do this and we can do this.
My
I'm not counting those.
one is connection lost. Everyone has connection lost.
Yeah.
Me too. Everyone has that.
I don't have connection lost.
Yeah, the whiteboard won't have a problem next time. I paid for the whiteboard, but I just didn't use my account. So I think it hasn't had this problem before, right? On Wednesday?
Yeah.
We didn't have these problems like last
Yeah.
time.
Okay, I'll sign in next time I make a whiteboard.
Okay, so I'm just going to draw in those lines of symmetry. So actually the hexagon has two different lines of symmetry. It has this one and this one. I mean, it has all the other ones too, but those are just rotated lines of symmetry, but it's the same kind of thing. So that's why I'm saying only these two lines of symmetry are different to each other. Okay, so someone drew a cross on the square, but I'm not going to count those lines as different lines of symmetry because
a cross still could be one if you had the right shape.
Well, actually, on the square, these are both lines of symmetry, but the second one is the same as the first one up to rotation, because if you just rotate this by 90 degrees, then we get the other line of symmetry. Now this line of symmetry is the same as this line of symmetry, because to get the second one, you just rotate by 90 degrees. Connection lost again. Okay.
Yeah.
Connection has always been lost.
Terrible, isn't it?
Terrible.
Yeah.
Yeah. Very terrible.
Very terrible.
But not
Terrible as it can be.
Wait, so now the final bit of the question is, okay. Final bit of the question. So there's two lines of symmetry here, which are different to each other. There's this line of symmetry, and there's also this line of symmetry. There are no other ones that are different to each other. Oh, actually, no, the square has one more, doesn't it?
Yeah.
Okay, so that means we have
I'm going to write the different ones.
Yes, the different ones.
Okay, I'm going to go back, and I hope it won't do it again.
I will also draw all the different ones once more. So we found 2 on the hexagon.
So are you doing it on the hexagon?
Yeah.
Okay. So 1, 2. You could do this one. You could split it in diagonal. Hey, who erased that?
I'll just draw it above because I can't see where you're writing. But there's this one and there's this one.
Okay, I'll just finish drawing the triangle here.
Yeah.
Oh, so there's this one, there's this one, there's this one, there's this one, this one, this one, this one, this one.
Wait,
This
Wait.
one.
the connection is lost again.
Yeah, I think, I don't know where you're writing because I
I
can't see it.
can't see
Oh,
your
can you-
picture.
Can you see like there's this high ot.k?
Why is everyone's computer are lost? Like iPads are also
Who does
I didn't rub
Okay.
anything out. Plus, I don't.
I'm going to write all of it
I
again.
have.
So wait, do you know there's a bit it says
I got connection lost. I can't see here and ot.k.
oh never mind, it's got rub. Who just keeps rubbing it out?
I'm not rubbing anything out.
How
like
about
not
if you're
robbing
having
Maybe
problems-
it's
I'm
just
just
not.
watching the computer.
I'm just looking and listening.
Okay, so
I think
I'll just have to write. I have to just like write the all of them again. Can you see?
Can I see? Can I see?
It's at the bottom.
It's at the bottom?
Oh, I can see it.
Wait, I can't.
There's like this. Oh, someone rubbed
Who
it.
just removed it?
I didn't remove it. I just saw it and
Oh,
then
can you still see a line left here?
sadly it removed. Let me draw one.
Yeah,
Let me draw one.
No, I can draw
very
it
good
again.
drawing.
Who keeps removing it?
I am not moving anything.
I don't know where you're drawing.
Okay, everyone.
Someone's
keeps
removing
doing
my
this?
drawing also.
Okay, everyone, even if you're having problems with your whiteboard, just pay attention to the Zoom, okay? Because otherwise we'll never get this done.
Okay.
Well, I didn't have connection lost anymore, so it's okay.
Okay. Okay, everyone just pay attention to the screen now. So, well, we found some lines of symmetry, right? These are all of the different lines of symmetry we found. So how can we put the shapes together? How can we glue them together to still maintain a line of symmetry so that the resulting shape still is symmetrical?
Who keeps picking them when I'm doing them?
I just ticked 1 and 2.
Oh, okay.
See one that wrote 3 and one that wrote 1.
Yeah, that means there's 3 lines of symmetry and 1 line of symmetry. This also has 3 lines of symmetry.
Someone in corner joined.
There's actually 4.
Someone called who?
Finn Con joined.
So anyone have,
Wait, can you see the things that I drew in the box right now?
No. Yeah.
Well,
can see
in this
anyone
long,
still have the
long
link?
blue box.
Guys, listen up. So one thing I want to say before I'm kind of go to see this other student. So basically, there's 2 playlists on YouTube. One unlisted that only you can see, and one public that everyone can see, and that should have all the videos for us in there. Okay. There's also maybe if you want to think about an extension question, is that So you might think, why is there only one line of symmetry? Okay, so the question could be interpreted as at least one line of symmetry or exactly one line of symmetry. Okay. And there's various other issues I raised, but that's probably the most tricky one.
Wait, I can't see anything.
Yeah, so I'll leave you with Yi, okay?
Yeah. I
Okay.
can't
Try
see
not to
anything.
complain about the connection so much and try to get on with it, okay, people?
Okay, so first let's just answer the original question, which is how to glue these together.
I can't see your screen. There's only a white blank.
Yeah.
Well, just focus on the
Anyone has a link?
so focus on the Zoom screen then.
Oh, I am in the link and someone keeps like removing something. I only have one thing left.
Someone's hacking.
Mm.
Okay.
Who's hacking?
So people, can you see how you might glue these together to make a line of symmetry? So that the resulting shape. So this is the question. How to glue them together so that the resulting shape has a line of symmetry. Anyone have ideas?
I don't really have any ideas.
Okay, well, let me just.
Maybe
Maybe.
Well, I'll give you some clues. So if I draw this shape, it has a line of symmetry here, right?
yeah, and then I'm just maybe
And then
you want why can't we can't see your screen like your screen in Google Chrome?
just look at Zoom. So you see how these two have only one line of symmetry?
Yeah.
If I glued them together, like if I rotate this one so that it looks like this,
And there's no one.
and the symmetry line is here. And then what if I try to glue these together like this? Does this have a line of symmetry?
No.
Yeah, so this has no line of symmetry because the lines of symmetry are here. So that means that the total shape has no line of symmetry. Do you agree? Because in the second shape, the only line of symmetry is here. And in the first shape, the only line of symmetry is here. So if you try to glue them together, but then you make one of the lines of symmetry different from the first line, then the shape resulting is no longer symmetrical. So that means when you glue the shapes together, we need the lines of symmetry to be the same.
Yeah.
This failed because we have different lines of symmetry in each of the individual shapes.
Yeah.
So does that give you any ideas?
Like different lines of symmetry.
Yeah.
So
You can't have different lines of symmetry in the original shapes. You need to glue them together. You need to keep the lines of symmetry the same.
yeah. The same.
The same.
So if the triangle only has one.
Okay, let's start with the triangle because you wanted to start with the triangle and it only has one over here.
Yeah, that's right.
And so then where can we put the square now once we have the triangle?
The square
Mm.
is one line and one line across.
So where can we put it if we want to keep the lines of symmetry the same?
We just put one line in the middle.
Okay, so it's going to have the same line of symmetry here, right?
Yeah.
So how can we draw the square?
Drawing the square. How can we draw the square?
Yeah, but how can we do it?
It's just draw a square.
Where? What do I have to attach it to?
A triangle?
Okay, so you mean you want to make the square like
Actually,
this?
no.
Is that what you're saying?
Okay. Maybe, yeah, maybe.
Yeah, this works because you're gluing them together and they both share the same line of symmetry now.
But the problem is, how about the hexagon?
Okay, well, all we need is that we need the hexagon to share the same line of symmetry, right?
And we can just use the hexagon to put it on the middle. Like that, the bottom of the square is the only thing that we can use now.
Okay, yeah, I think you're right. So we can do this now. Because then we have all the lines of symmetry are shared. So this is a success. For the triangle, we used this line of symmetry. For the square, we used this line of symmetry. And for the hexagon, we used this line of symmetry. So this is one way and it works. Can we do another one? So again, we need to just keep the lines of symmetry the same. So let's start with the triangle again, just because we did that last time and someone wanted to.
Yeah.
We could start with any shape really, but let's just start with the triangle.
We can also do like, there's also another way. Not like a big way, like, I'm just saying that like, we can just use the hexagon and the square. I didn't count, but like, let's just think like, if we use that and then put a square.
Yeah, this works.
Not the, that does work, but like, they say,
it's
he must
different.
have done this. Oh yeah, okay. That's the second one, yay.
Yeah, it's actually different. They're different shapes because you can't rotate or flip any of them to get the other one.
That's right.
Yeah, but there's actually more ways we can do, aren't there?
Yeah, there's more ways. Like,
let's start with the triangle again. I'm starting with this because it only has one line of symmetry. But then, I mean, for this shape here, the second shape, we used exactly the same lines of symmetry. We used just the vertical ones, but we haven't even tried using the diagonal ones yet. We haven't even tried using these lines of symmetry yet. So how can we, I guess, is there a way?
Well, we just do two ways and that's it, right?
Yeah, that is the end of the question, but I'm wondering if we can somehow use the red lines.
My background is me.
Wait.
Okay, well, I think that, I mean, I don't think we're allowed to do this kind of thing, so.
I think the meeting should be end like 15 minutes ago.
Yeah, I think so.
What should we do?
Let's just answer this extension question and then we'll go, okay?
Okay.
So this extension question said, why is there only one line of symmetry? So
this is because that the triangle has one line of symmetry.
Yes, perfect.
Yeah.
Yes.
Oh,
so that's because the triangle only has one line of symmetry, and since when we glue the shapes together, we need them to share lines of symmetry, then there's only one line of symmetry that can be shared by all three shapes
Yeah.
because the triangle only has one line.
Yeah.
Okay, good,
That's
very
fine.
good.
I answered it. Yay.
Good.
Let's go.
But you answered it, but you want to be good at explaining it. It's because they share the same line of symmetry, right?
They share the line of symmetry.
And
If the triangle has one line of symmetry,
mhm,
then it forces all of the shapes to
Mhm.
have one line of symmetry to make them all equal.
yes, exactly. It forces all of the other shapes to have the same line of symmetry. Good. Okay. Good job, everyone. We did A, B, and C, and we can quickly think about D next time.
Let me think of the next later.
And D is, I think you can think about it yourself, but
Hexagon is with a 10.
yes. So decagon is 10 sides.
10 sides, yeah.
And I think it has 2 lines of symmetry, right? So I
2
think,
lines.
yeah, well, it says that Alice makes a shape that has 2 lines of symmetry. So I think that what you found out is that you can't use the triangle. Why
Yeah,
can't you use the
definitely
triangle?
not.
Why not?
Because the triangle only has one line of symmetry.
Yeah, exactly.
And
Yeah.
I think I know it.
Ah, good job. So next time you can show me after you figure it out.
Maybe 2 squares and 1 hexagon.
Maybe. I think
Okay, I'm
that's
going
really
to
good.
type the greater of a decagon.
Okay, good job, everyone.
Why is why is this here?
Oh, you're charging your iPad. Let's go. Bye.
What?
Bye.
Bye. I'm gonna
Bye.
end the meeting.
Okay.
Okay.
Bye-bye.
Bye.
I'm just gonna wait until